Okay, welcome everybody. Let's see. Okay. Oops. Okay. Let me just start the recording. And okay, welcome everybody. Does anybody have any questions? Okay, so I will adjust our homework for this week after the class. And I'm talking about the web assigned homework. And we also have Khan Academy homework due on Monday. So please do that. And so if there are no other questions, I'll start. Okay. Okay, so we have talked about the mean, and I think we've done that enough. And the next thing we want to do is talk about the median. So let's take a look. Okay, so we talked about the mean. And we said we'll use either X bar or mu, depending on whether it's from the sample or if it's from the population. Those are just the symbols. And then we have the definition is sigma x sub I over, and then we either write capital N or small n here, depending again on if it's the sample or the population of the sample. Okay, so let's take some numbers like 2, 4, 6. Well, let's say 8 and 10. Okay, so we have 5 numbers there, and I think it's pretty clear that the mean is 6. It's right in the middle. If you add them all up and divide by 5, you're going to get 6. So that's the mean. And we saw that if you change one of the numbers, for example, sometimes you're recording numbers and for example, you add an extra 0 there. So if that happened by mistake, now we have these numbers, and we call this an outlier. Oops, I can't do that very well. We call this an outlier, and it's going to change the mean by a lot, right? If we take 2 plus 4 plus 6 plus 8, so that's what, 6, 12, 20, and then plus 100 equals 120. And if we take 120 divided by 5, we get a much different number than 6. In fact, we get what? 24, right? 24. Okay, so it went up by a factor of 4, actually. So therefore, we can say that the mean is sensitive to these big numbers. We called it an outlier. So you can say the mean is sensitive to that, meaning if you have an outlier, it's going to really change things. Okay, now let's talk about it. But rather the mean is called. You might say, what do you mean by sensitive? Well, I mean sensitive as compared to the next thing we're going to talk about, which is not going to be so-called sensitive to outliers. So we're going to talk about some other thing, the median, soon. Called a measure of the center. The mean is called a measure of the center. and that's pretty clear. It's supposed to measure the center of the numbers. Sorry, 2, 4, 6, 8, 10. It's supposed to measure the center of that, and the mean is 6. That's kind of the center. Okay, but we have other measures of the center as well, and another one is called the median. And the median is obtained in a different way. The median, what you do is if you have 5 numbers, let's change them. Let's say we have 1, 2, 9, 20, and 4. Okay, first of all, to get the median, you have to rearrange them in order. So we'd have to write them 1, 2, 4, 9, 20. So that's what you have to do first. And then what you do is you choose the number which is in the middle number. So here there are 5 numbers, 1, 2, 3, 4, 5. So the middle number is going to be the third number, which is here. So that will be defined to be the median. So the median is the middle number, and it's 4. Now, if you have an even number of numbers, here we had 5 numbers, which is an odd number of numbers. So if it's an even number of numbers, we do it slightly differently. But right now, let's just say that it's the middle number, and it's equal to, in this case, 4. Now, the mean, what is the mean? If we wanted to calculate it, might not come out very well, but we would get, we get 3, and 4 is 7, and 16, and 20 is 36. So it doesn't work out that well. It's 36 over 5, which is about 7.2, right? I think that's 7.2. Whatever it is, it's not the same as 4, right? So the mean and the median are not the same thing. Now, 7.2, we could say, is the center of this set of numbers, or we could say that 4 is the center. So the word center is not exactly well defined or clearly defined. So we could say that it's 4, we could say that it's 7.2. However, the word mean is clearly defined. We know exactly how to compute it. We can't say that the mean is 4. We can only say that the mean is 7.2. It's clearly defined. Okay, so the mean is clearly defined, and the median is also clearly defined, at least when we have an odd number of elements in the set. Now what happens to the mean if we get an outlier? Like suppose this 20 becomes 200. The median, what did I say? What happens to the median if we get an outlier? So the mean is obviously going to change a lot, right? When we change that 20 to 200 and then calculate the mean of that, it's going to be much bigger. But what happens to the median? Does anything happen? And the answer is no. The median doesn't change at all. So we can say that in general, the median is not sensitive to outliers. So that whereas the mean is sensitive to outliers, the median is not. Okay, so that's the idea of the median, and it's also measuring the center, and sometimes we might prefer to use the median. And I believe that in when countries report their distribution of incomes, usually you say, okay, how many people make $50,000? How many people make $60,000? How many people make $70,000? And so on. So you have this kind of curve. Now, this kind of curve tends to be, doesn't have to be, but it tends to be skewed to the right. We talked about skewed to the right, and it tends to be skewed to the right, which means that there are going to be a few people that are very rich. Now, in different countries, it'll look different, but this often happens that it's skewed to the right. Now, it seems like in economics, they usually don't report the mean income. They usually don't give that number. They usually report the median. And I guess the reason is, I don't know the reason, but one thing we can say is that the median is not going to be sensitive to outliers. So if somebody earns a whole lot of money out here, the median may not change at all. So the median is not exactly sensitive to the high income earners. So I don't know why they would want to report that. But, well, I guess they're trying to, I guess the answer is they're trying to find some number which is representative of the whole population. So the fact that one person earns a whole lot of money would skew the mean, but it won't skew the median. And if you want to talk about what typically people earn, maybe you don't want to include that super high number as being a big factor. Okay, so we talked about. Okay, let's have a group session here, group exercise. So let me. Okay, and I'll give you one exercise. Oh, I didn't add you. Oops. Okay, did everyone finish yet? Is everyone finished?
Yeah.
Okay. All right. Actually, I meant to put us in breakout rooms, but I didn't do that. Okay. So let's look at the answer then. Okay, I'll stop it.
Professor, I'm not done yet.
Okay, I'll give you a little more time. Okay, anybody need more time?
Yes, Professor.
Okay. Okay, anybody still need more time? Okay, I'll close it. Okay, and let's just take a look at that one. Okay, so what's the median of these numbers? So how do you do this? You have to line them up in order first. So in other words, you have to do 1, 4, 6, 9, 15. So 1, then 4, then 6, then 9, then 16. So, and there are 5 numbers altogether, right? So it's 1, 4, then what's the middle number?
6.
6, right? So that's the median. Okay, and what about the second one? Which is more sensitive to outliers?
The mean.
The mean. Okay, the mean is the sensitive one, sensitive to outliers. Okay, all right, let's take a look at one other example. So suppose that I have, can everyone see the screen?
Yes, Professor.
Okay, so let's suppose that, that we're working for a company, and there are 19 employees and 1 president. And there's a union, and the employees are all members of a union, and they're trying to negotiate. How do you spell negotiate? Negotiate, maybe, I don't know. Negotiate with the president. They want to increase their salary. Okay, everyone understand the scenario? So they want to increase their salary, and let's say that the salaries look like this. The first employee gets 1 million yen. The second employee gets 1 million yen per year. The third employee gets 1 million. 1, 1. All 19 employees get 1 million yen per year. And then the president, let's say, gets 201 million yen per 201 million yen per year. Okay, does everyone get it? Does everyone understand the scenario? Can you see my screen?
Yeah.
Okay, so that's it. There are 19 people with getting 1 million, and then the president gets 201 million a year. And so these people, the employees, they're saying it's not fair. Not fair. We want higher salary. Give us higher salary. So, but the president says, I think it's very fair. He says, I think the salaries are extremely fair. And why are you all complaining? It's fair. And so they're both making arguments. Does everyone get it? They're both making arguments. So they both want to talk about the typical salary. Okay? And the president wants to say, I think it's very fair. President says fair, and the workers are saying, unfair. And they both want to make their arguments. And so they want to say, oh, the typical salary. So the president is going to say the typical salary, and the workers are going to say the typical salary. So one of these two people in the argument are going to use the mean, and the other are going to use the median. So who is going to use which? So the president is going to say, I think the typical salary is, and the workers are going to say, I think the typical salary is. So who's going to use what to get the typical? You can use your own voice. You don't have to use the chat room. Who's going to argue which?
The workers are going to use mean.
The workers are going to use the mean, he says. Okay, so if the workers use the mean, what is the mean of this? So it's 1 plus 1 plus 1 plus 201 over 20, right? So what is that? Can we do that, or is that hard to do? 50, isn't that, what is that? Somebody do that. My brain is not working. What is it?
11.
11, okay. Okay. So the workers are going to use the mean, so they're going to say it's 11, and the president is going to use what? Same person who answered the other one.
The median.
Okay, the president is going to use the median. So what's the median here?
1.
This one.
Oh.
I don't think they're going to do it like this. Do you? The worker is going to say, "Oh, the average salary is 11." No, the workers are. It's the other way around, right? The president is going to use the mean. He's going to say, "Oh, what's wrong? This company is great. The average salary in our company is $11 million. I'm sorry, 11 million yen per year. What's wrong with that?" Right? But the workers are going to use what to talk about the typical salary? They're going to say the median. The median is 1 million yen per year. Okay, does everyone understand? It's kind of a joke, but does everyone understand?
Yes.
Okay, so the president's going to use the mean, and he's going to say, "Oh, you guys are just big complainers, and go away. Just go back to work, because the average salary or the mean salary is 11 million yen per year. So that's good. That's a very good company." And the workers are going to say, "No, no, no. The average salary is, or the typical salary is 1 million yen per year, and that's not good." Okay, so who's right? Who is correct? Well, I guess we could say they're both correct, because they're both, he said the mean is this, and they said, or she said, whatever, and they said the median is this. So they're both correct, but I don't know who's morally correct. But anyway, does everyone understand the situation?
Yes, Professor.
So the mean and the median are both called measures of the center, or the typical value, or whatever you want to call it. But they're not the same. Okay, all right, let's go to another question. Let's ask another question. So let's go to Okay, I'll open up another question here. Okay, so try and do that one. Should be open right now. Oh, wait. Sorry, don't do that one yet. Wait, don't do that one yet. Or you don't have to do that one yet. Let me do a different one. I think I skipped one. Did I skip one or not? Let me see. Let's see again. Yeah, I skipped one. Sorry. Let me do another one somehow. I don't know how that happened, but let me go here. Did I open the right one? Let me see again. Okay, try that one. Did we just do that one? No. Okay, you have 10 seconds. Okay, I'm going to close it. Okay, does anybody have any questions about that one? Can I skip that one? Not review it? Okay, so let's go back to here. What does this say in green here? I'm not sure if you can see the whole thing, but what does it say?
The median is very sensitive to outliers.
Right. However, the median is not particularly sensitive to outliers. Okay, so we've made that point. Okay, let's go on to here. Change at all. So we can say that in general, the median is not sensitive to outliers. So that whereas the mean is sensitive to outliers, the median is not. Okay, so that's the idea of the median, and it's also measuring the center, and sometimes we might prefer to use the median. And I believe that when countries report their distribution of incomes, usually you say, okay, how many people make $50,000, how many people make $60,000, how $70,000, and so on. So you have this kind of curve. Now this kind of curve tends to be, doesn't have to be, but it tends to be skewed to the right. We talked about skewed to the right. And it tends to be skewed to the right, which means that there are going to be a few people that are very rich. Now, in different countries, it'll look different, but this often happens that it's skewed to the right. Now, okay, so incomes are skewed to the right. And so which is preferable to use to report the income of a country?
Median.
The median, right? Because the mean will be very skewed to the right by a few rich people. So we don't really want that. Okay, let's go on here. Okay, so what do we do if we have more than, if we have an an even number of elements in the set? How do we calculate the median? So we might have 1, 2, 3, 8, 10. That would be 5 elements. And let's add one more, let's say 20. Now, again, whenever you calculate the median, you have to line things up from least to greatest, but I already have them like that, so I don't have to do that. But now, where is the median? Normally we would say it's right in the middle, but we don't have an element right in the middle in this case because we have 6 elements. So in that case, what they do is they just take the 2 closest elements to the middle, which would be this one and this one, and they just take their mean. Okay, so we take, to get the median, we just take 3 plus 8 over 2. We take the mean of 3 and 8. So that's 11 over 2, which is 5.5, right? So we would say that the median is 5.5. So that's what you do when you have an even number of elements. Okay, so we talked. Okay, so let's try a group one. I hope I can get it working this time. Okay. Okay, and let's see. Oops, can't do that. Okay, I'll close it. Okay, so here's the question. So what's the median for these numbers? So again, you have to line them up from least to greatest, but it's already in least to greatest now. It's already aligned. So what do we do with these numbers? We want to find the middle value. So, but there is no middle value. So we look at the 2 closest to the middle, which is 5 and 7, and we calculate their mean. The mean of 5 and 7 is 5 plus 7 over 2. So that's 6.
Sorry, sir. This is the individual one.
Oh, did I do the wrong one?
What we just did is the group one.
Okay, thank you. Thank you. Okay, so I guess we just did this one. Oh, thank you. Okay, so here it is. So 13599 1000. There are 1, 2, 3, 4, 5, 6 elements. So we want the two closest to the middle. So that would be 5 and 9. So we'll take 5 plus 9 over 2. So that's 14 over 2, which is 7. So the answer would be 7. All right. All right, now we're going to talk about something new, something different, something called the geometric mean. Okay, so it's a different calculation than the mean. And it's a different calculation than the median as well. And you can see this formula here, the so-called geometric mean. There's a little g there. The so-called geometric mean. So if you have a bunch of numbers, which, can you see my screen? I mean, sorry, can you see this here? I'll do it here. I'll do it here. Okay, so if you have, let's see, this. Okay, so here. Okay, so let's suppose we have a bunch of numbers like 2 and 3 and 4 and 6 and 8 and 5. So we know how to calculate the mean. If we call this one x1, x2, and so on, the mean is just we sum them all up and we divide by the total number. That's the mean. And we also know how to calculate the median. Okay, now we're going to talk about something called the geometric mean, which is a different calculation. And that is, you take the product. So here we're adding them, right? We're taking 2 plus 3 plus 4. We're adding up the numbers, right? But for the geometric mean, we're not going to add them up. We're going to multiply them. So we're going to do 2 times 3 times 4 times 6 times 8 times 5. Okay? And then we're not going to divide by the total number of elements, which is 6. There are 6 elements here. So we're not going to divide by 6. We're going to take the 6th root. Okay? Does everyone get this idea? So let's try it with a really simple case. Let's suppose the numbers were 2, 2, 2, 2. Okay? So if I ask you for the mean of those numbers, what's the mean for these numbers?
2.
2, right? It's 2 plus 2 plus 2 plus 2 divided by 4, which is 8 divided by 4, right? Which is 2, right? And if I ask you for the median, well, just for an exercise, if I ask you for the median, what's the median of these?
2.
Median is also 2. By the way, sometimes some books might use this symbol for the median, okay, with a little line in the center there. But anyway, it's 2, right? Okay, but how about this calculation? If we want to do the geometric mean, what we do is we take all the elements and multiply them, and then take the nth root, or in this case, the 4th root. In this case, it would be the 6th root. So let's do that. 2 times 2 times 2 times 2, and then we take the 4th root, because there are 4 elements here. So then what do we get? This is 4 times 4 is 16, and we take the 4th root. So what is that?
2.
It's also 2, right? Okay. So then anyway, but that's a simple, easy calculation, because I used all the same numbers. But in general, if you wanted the geometric mean, by the way, the symbol for the geometric mean is that with a little g there, or that's the symbol they use in this book. So you take, what do? You do 2 times 3 times 4 times 6 times 8 times 5. That's here. And then since there are 6 numbers, you take the 6th root of whatever this is. And that would be called the geometric mean. And this is useful in places where the regular mean may not really give us what we're looking for. So sometimes this is more useful or more appropriate than the regular mean. So let's take a look at this. About the mean and the median. Now we want to introduce one more kind of mean called the geometric mean. The geometric mean is a measure of location that is calculated by finding the nth root of the product of n values. So to calculate the mean, we didn't take the product of n values, we took the sum of n values, and we didn't take the nth root of that, but rather we divided by n. So this is different. So the geometric mean is calculated by finding the nth root, not by dividing by n, and not of the sum, but of the product of the n values. So for example, if we had n values, x1, x2, xn, then to get the geometric mean, we don't add these up, we multiply them, and we don't divide by n, we take the nth root. So this is called the geometric mean of these n items. And we can write it like this, of course, because we can write the nth root like this. So one place where the geometric mean is used frequently is in analyzing growth rates in financial data. In these types of situations, the arithmetic mean, or the average value, will give you misleading results. So let's look at this. Percentage annual returns and growth factors for the mutual fund, for mutual fund data. So mutual fund is an investment you can make in the stock market. And then each year the value of the mutual fund has either increased or decreased or could have stayed the same. So we can talk about the return of the mutual fund. So if it decreases, then the return is negative. And if it increases, the return is positive. So here we have a series of years. This is at the end of the first year, at the end of the second year, and so on. So anyway, let's suppose we put in $100 at the beginning into the mutual fund at the beginning of the first year. And suppose that it dropped. Suppose that it dropped by 22.1%. So if it started at 100 and it dropped by this amount, then how much would you have? You'd have $77.90. So unfortunately, you would have lost money. You would have lost $22.10, which would leave you with $77.90. So the return is negative 22.1. That's the percentage drop. And the so-called growth factor is this. In other words, if the growth factor was exactly 1, that would mean that you started with $100, you would end up with exactly $100. If it's less than 1, then it means that you started with $100 and you have less than $100 at the end of the first year. And this is the factor that you use to multiply 100 by to know how much money you have at the end of the first year. So what happened here in the second year? Well, it wasn't 1, it was above 1. That means it increased in value from the beginning of year 2 to the end of year 2. And it increased by basically 128, about 128%.
That's wrong. I said that wrong.
So it increased. Or wait, I'm sorry. I should say it increased by 28%. It increased by 28%. Okay, what happened in year 3? So year 3, the percentage return was this, and the amount and the growth factor is this. This means that basically it increased by 10.9%, or maybe we just make it easy and say by about 11% over the over that year. It increased by 11% over that third year, meaning from the end of year 2 to the end of year 3, it increased by about 11%. So that is what is meant by the growth factor. So in the first year, the return was negative 22% about. The second year, the return was 28, maybe even 20, maybe 29%, we could say, approximately. So we got an increase there. So whatever it was at the beginning of year 2, it increased by about 29% over that year. In the third year, it increased by about 11%, and so on. Okay, let's continue with the geometric mean. So they say to illustrate those numbers. Okay, let's have an exercise. So let's go to here. Okay. Okay, I'm going to close it. Okay, let's check it. Okay, so let's look at the first one. So the growth factor is the number we multiply the value of the investment at the beginning of the year to get the value at the end of the year. Is that true or false?
True.
True.
Okay, good. The answer is true. So going back to that picture, here, well, actually it's not here anymore, but is it anywhere on this video? Here, going back to here. So the growth factor was 0.779. So we will take the initial value, which was $100, and multiply it times this, and that will tell us how much we have at the end of the year. So we'll only have $77.90. Okay, so like the problem said, the growth factor is the number we multiply the value of the investment at the beginning of the year by to get the value at the end of the year. So that's true. Okay, if an investment was worth $500 at the beginning of the year, and the growth factor was 1.1, so how much would the investment be worth at the end of the year? How much would it be worth at the end of the year?
150.
550, right. Because we multiply, this is the growth factor. It started out at 500 and the growth was 1.1. It means it increased by a factor of 1.1, which means 1.1 times 500, which is 550. Okay, any questions about this? Okay, let's do another one. Let's try this one. So try that one on your own. Okay, I'll close it. Anybody need more time? Yeah, I'll close it. Okay, so let's take a look at this one. So if an investment was worth 500 and the growth factor was 1.2, what would it be worth at the end?
600, Professor.
Right, 500 times 1.2, which is 600. Okay, let's continue here. Okay, let's continue with the geometric mean. So they say to illustrate those numbers, to illustrate the use of the geometric mean, consider this table, which shows the percentage annual returns or growth rates for a mutual fund over the past 10 years. So we just looked at that table. Suppose we want to compute how much $100 invested in the fund at the beginning of year 1 would be worth at the end of year 10. Okay, so let's take a look at that. So how much is it worth at the end of year 1? How much is the $100 worth at the end of year 1?
77.9.
Yeah, the growth factor was 70.779. It dropped by 22.1%, that's why it's 779. And so if it started at 100 and it dropped, this is the growth factor, it dropped, and it's only worth $77.90. Does everyone agree with that?
Yeah.
Okay. So then what happened in the second year? Did it increase or decrease during the second year? During the second year.
Increase.
Yeah, increase, because if the growth factor is greater than 1, then it increases. If it's less than 1, then it decreases. So in the second year, it increased. But what did it start out as? At the beginning of the second year, what did it start out as? How much was it worth at the beginning of the second year? Yeah, we just said it was worth $77.90. Now it's going to increase from there by this amount. Okay, so how much is it worth? We have to do the calculation. It's going to be this number times this number, right? Times 100, right? Does everyone follow that? So it's going to be the $77.90, and that's going to increase. So we're going to multiply the $77.90 by 1.287. Okay, does everyone follow that? Everyone that's actually paying attention? The people who aren't paying attention, you don't have to answer. Okay. All right, let's go through this. Use of the geometric mean. Consider this table, which shows the percentage annual returns or growth rates for a mutual fund over the past 10 years. So we just looked at that table. Suppose we want to compute how much $100 invested in the fund at the beginning of year 1 would be worth at the end of year 10. Let's start by computing the balance in the fund at the end of year 1. Because the percentage annual return for year 1 was minus 22.1%, the balance in the fund at the end of year 1 would be $100 we started with, and then it went down by 22.1%. So that's 22.1% of $100. So this can be rewritten like this. I guess we can factor out the 100. We get this, and we get that the growth rate is this part in the brackets, which is 0.779. And when we do that multiplication, we get what we would have at the end of the first year. They say we refer to this number as the growth factor for year 1 in that table that we saw. We can compute the balance at the end of year 1 by multiplying the value invested, that is the $100, in the fund at the beginning of year 1 times the growth factor, 0.779. So the growth factor is 1 minus the 1 minus the percentage annual return, right? It's 1 minus the percentage annual return is the growth factor. All right. So anyway, the growth factor is 0.779. Okay, let's keep going. Okay, so the balance in the fund at the end of this year was this. That now becomes the beginning balance in year 2. So with a percentage annual return in year 2 of 28.7%, the balance at the end of year 2 is going to be 28.7% higher than what we started with, which is this much. So it's going to be what we started with plus 28.7% of that, which is this, which again, we can factor the 77 out, and we get 1 plus, that's going to be the growth factor. So this is the growth factor here. Okay. Note that 1.287 is the growth factor for year 2. And by substituting 100 times that for... Okay. So how much do we have? Okay, once again, or looking at this screen, how much did we have at the end of year one? How much did we have at the end of year one?
77.9.
77.9, right? Now, what was the growth positive or negative in year two?
Positive.
The growth was positive. It went up by, according to the table, it went up by 0.287%. Okay, it went up by that amount. So we ended up with the $77 that we started with at the beginning of the second year times the increase, right? 1.287. Does everyone agree with that?
Yes.
So at the end of the second year, we have now $100 or $100.25 or whatever, $100.2573, right? Everyone agree with that?
Yes.
Okay. So the calculation that in order to get this 100 was the 77 times the growth factor for the second year, right? This is the growth factor for the second year, right? Agree?
Yes, Professor.
Okay. But we can rewrite this 77. Where did the 77 come from?
First year and
It was that was the end of the first year. And how did we calculate it? We took the initial $100 that we put in and we multiplied times the growth factor in the first year, right?
Yes.
So we can rewrite this 77.9 as the initial balance, which was $100, times the growth factor in the first year, right? So instead of writing this, we can write these two pieces here, right? Everyone agree with that?
yes.
Yes.
Okay, so at the end of the second year, instead of writing it this calculation, we could write it like this calculation, right? With these three terms instead of just these two, because we took the first term and we wrote it as two factors, this one and this one, right?
Yeah.
Okay. So what we can do is, if we wanted at the end of the third year, we could, well, let's keep going. 77.9, we see that the balance in the fund at the end of year two is, so we could do, instead of writing 77.90, we could say, well, this is what we started with at the beginning of the entire investment process, $100. Then we did this to it, which made it smaller. And now we're doing this to it, which is going to make it bigger. And the net result is that at the end of the year two, this is our balance, or that's the value. In other words, the balance at the end of year two is just the initial investment at the beginning of year one, times the product of the first two growth factors. This result can be generalized to show that the balance at the end of year 10 is the initial investment times the product of all 10 growth factors. So we can start with, want to know how much is it worth at the end of 10 years, you take the beginning balance, which was 100, then the growth factor is 0.779. So that gives the product of those two, gives you how much it was worth at the end of the first year. Then you take that and multiply it times the growth factor in the second year to figure out how much it was worth at the end of the second year. And then you take that and multiply it times the growth factor in the third year to figure out how much it was worth in at the end of the third year. And you keep doing that. So what we're doing is we're multiplying all the growth factors. Is that clear?
Clear.
Yes.
So to get the value at the end of the 10 years, you take the $100 that you started with and then multiply all the growth factors and then you get the final value at the end of those 10 years. And it turns out to be $133 and something, right? So how much money did we make in the 10 years, approximately?
$33.449.
Right. Okay. So we made 33.44 something. So we made about $33 over the 10 years. Okay? Everyone understand that?
Yes.
Okay. So let's keep going. With 100, growth factor, growth factor, growth factor, growth factor, multiply them all out, and we get the final result, which tells us that the amount we'll have at the end of the 10 years is this, 133 and something. Okay, so here they say, so $100 investment. Okay, let's go to another exercise. So let's go to this one. Oh, sorry, we have to go to group. Okay, let's go to a group. Just a short one. Quick one. This could be $1,000 in fund. Okay, I'm going to close that one. Or actually, yeah, I'm going to close it. Okay, so what does it say? Suppose we're given 5 growth factors for an investment over 5 years. To get the balance at the end of the 5 years, we can multiply the initial value of the investment times the 5 growth factors. This will give the value of the investment at the end of the 5 years. Is that true or false?
Professor, I didn't
Let's confirm it. Can I confirm it? I choose true.
Okay, right. That's right. It's true. Anybody else? Any questions? Okay.
Professor, can you open it again? I didn't submit it.
Oh, I already gave the answer, so it's too late.
Okay.
All right, now. Oh, okay. Now let's do a individual one. So you can check that. Wait, let me make sure about that. Hold on. Actually, no, I don't want to do that one yet. Okay. All right, now, so let's think about this. So let's say that we have okay. So let's say we have a growth rate of 0.78, and then we have another growth rate of 1.2, and then another growth rate of 1.1, and then a growth rate of 0.9, and then a growth rate of 0.6, and then a growth rate of 1.5. Okay, so, and we start out with $100. So how much is it worth at the, let's see, there's 1 year, 2, 3, 4, 5. How much is it worth at the end of the 6th year? How do we figure that out? How much? What's the calculation?
100 times 0.78 times 1.2 times.
Right, okay, thank you. Right, all of these, right, times 0.9, times 0.6, times 1.5, right? Everyone agree with that? Okay,
Yes.
and in the last example, we had 10 years. And what was that? What did it look like? It looked like, here, you can see it up here, right? So it's like 100, and then you do all of those, and you end up with 133. Does everyone see that?
Yes.
Okay, so let's write that down. So you start out with 100, and you multiply by all these factors. There's 10 of them, and you end up with about 133. Okay, so how much money did we make in the 10 years again?
33.
Right, $33. Okay. Now, suppose I want to know how much would I have to make every year in order to start with 100, and in order to start with 100 and end up with 133. How much would I have to make per year? Or what growth factor per year would I need? Would I need?
1.33.
Does everyone understand the question?
Yes. Yes, Professor.
So I want the same number every year, the same growth factor every year. And then I want to end up starting with 100, I want to end up with 133. Okay, does this make sense, this question?
Yes, Professor.
Okay, so that's the question we want to think about. So you might think like this. You might think, well, I have to increase by $33, right? So I need a growth factor of 1.3 over the 10 years. Over 10 years. Does everyone understand that? I need a growth factor, a 10-year growth factor of
1.33, right?
Yes.
Yes, Professor.
Okay, so now you might think, okay, well, if I need that in 10 years, then each year it should be 0.3, I'm sorry, it should be 0.33 divided by 10 for each year. So that's what? What is this equal to? 0.33 divided by 10? Equals that, right?
Yes.
So you might think, okay, well, I need this per year. I need that growth factor per year in order to get a 10-year growth factor of this. Does everyone understand that logic?
Yes.
Right? If this is the
Sir,
growth factor,
I
yes.
think that should be like 10th root of the 1.33.
No, I agree with you, but I'm just saying this sounds reasonable, right? In other words, if you want to get 33% increase over 10 years, it sounds like you should have 0.033% per year, right? Does everyone understand my thinking?
Yes.
I don't really understand.
Yeah, so that sounds right, but it doesn't work. It's not right. Okay, but it sounds like it's the right thing to do. So it sounds like if we had 0.033 per year, and if we did that for 10 years, then we would get 10 times that, or 33% increase, right? Or yeah, 33% increase. But it's not true. It doesn't, that's not the way the math works. Okay? If you had this increase every year, then you would end up with more than 133 actually. Not 133, but you would end up with more than that. You don't need this much per year in order to get this. Okay? So basically when I calculate this number, I'm calculating the mean. I'm calculating, actually I'm doing kind of like an X bar calculation, but that's not the right calculation. It turns out we want an X bar G, or the geometric mean calculation, instead of this. Okay, so anyway, this is not the correct calculation. Okay, but it seems like it should be right. It seems like if you did this every year, then you would get this growth, but it's not right. So let's look at it.
Okay, so here they say, so a $100 investment in the fund at the beginning of year 1 would be worth this amount at the end of year 10. Note that the product of the 10 growth factors here is 1.334. So if you just multiply the growth factors without the 100 there, you get 1.33 whatever. Thus, we can compute the balance at the end of year 10 for any amount of money invested. So it doesn't have to be $100, could be $1,000. You would still multiply it times this. By multiplying the value of the initial investment, $1,000, for example, times this number. For instance, an initial investment of $2,500 at the beginning of year 1 would be worth 2,500 times this number, or this amount. Okay, so the next question we might like to know is, what was the sort of average annual return? So we know that the overall return is this growth factor here. That's for the 10 years. We also know that for the first year it was this here, and then it was this one for the next year, and so on. And that for the 10 years, the average, the overall growth factor was this. But what do we need to, if we wanted, what do we need to have on an annual basis in order to achieve this over 10 years? That's the question. So you might think, oh, well, maybe it's like 1.5 or something. I'm sorry, 1.05. And then, so you get 1.05 the first year, and then you get 1.05 the second year, and then you get 1.05 the third year. So we're asking, what would it have to be every year, the same thing every year, to achieve this at the end? So, as I said, well, let's see, there were 10 of these, right? So 10 years, in other words. So you might say, well, this is 33. So in order to get 33 over 10 years, you should just divide the 33 by 10, which would be 1.03, or 1.033, or something like that. So, but that won't work. If you take this number, 33, and divide it by 10, and then assume that that's what you would need to get every year in order to end up with this, that's not correct. Because these are being multiplied by each other. And when you divide by 10, you're basically getting the mean where you would be adding up all of those means. But in actuality, these are being multiplied, so it doesn't quite work that way. It's actually the geometric mean that we want of these numbers, which will give us the correct annual growth rate that we would need to achieve this over the 10-year period. So we want the geometric mean of, all right, it's really hard to use this, of this is these numbers here. So, but we already know what these numbers here multiply out to. It's this. So we want this, and then we want the 10th root of this number. So it's not dividing by 10. It's the 10th root is what we want. So here it's written here, and it's written like that. And that turns out to be 1.029.
Okay, so it's 1.029. Now, what did I guess that it was? What did I guess that it was on my board?
0.03.
Yeah, I didn't guess that it was 1.029. I guessed that it was this. So they just told us that it's not, it's 1.029. But I was guessing this because I took this number and divided by 10, just this part, divided by 10, that gave me 0.033 per year. And I thought that's going to add up to this. And so that's what it should be. But is it more than what I guessed, or is it less than what I guessed?
Less than what you guess.
Yeah, it's less. You don't need as much as the calculation that I did would make you think you need. Okay? You only need this number. This is the, what do we call this?
Geometric mean.
It's the geometric mean. Okay? And how did we get it? We took all those numbers, all the growth factors, we multiplied them, and then we took the 10th root, right? And that gave us this. Okay? So that's how you get the annual return necessary to achieve the overall return.
And it's written like that. And that turns out to be 1.029. 1.029. So I had guessed that it would be 1.33. I'm sorry, 1.033. But it's 1.029, so it's less than. That is, we don't have to have like a 0.033 increase every year in order to get this as the final result. That is, this as the final result. We only need to have this, so it's actually less on an annual basis than we would have thought if we had sort of calculated the mean, which means some, or dividing this by 10, for example. Now they tell us that in Excel, you can use an Excel function to get this number. So you put in 1.33 into something, and the way you do that, they say earlier up here somewhere, was, where is it? Oh, here. The nth root can be, so we want the 10th root. So the nth root can be computed using most calculators or by using the power function in Excel. For instance, using Excel, the 10th root of this number, use equals, power, open bracket, the number that you want, comma, there's a comma there, and then 1/10. And that will give you this number here. So again, what's the interpretation of this number? This number here, or this number here. It's what you would need to get every year in order to end up with the 1.33 over the 10 years. So in other words, you'd get this every year, then we know that we would multiply each year times this number. So we'd do to the 10th power, and we would get times 100, and we would get the result that we needed. Okay, if I didn't say clearly enough why we don't want to use them. Okay, so let's go to, let's take another exercise. Okay, let me do one thing here. Just 1 second. Okay. Okay, let's have one more. Let's do this together. Okay.
Okay, I'm going to close it in 15 seconds. Five seconds. Okay, I'm closing it. Okay, let's take a look at that one. So what's the answer here?
Smaller.
Smaller.
Smaller, right. That's the point we just made. That I would, just like before, I would have guessed that it was 1.033, but I was wrong. It was actually less than that. Okay, and the same thing here. All right, let's quickly go to the last one here. Okay, so the next measure of measure of location is percentile measure. So you often see this like when you hear about SAT scores. So you might have gotten, say, a 720 on your math SAT, but they also tell you, oh, that was the 94th percentile. So what does that mean, that it was the 94th percentile? So it means that you did better, or your score was higher than 94% of all the test takers. And your score was worse than 6% of all the test takers. So that's what the 94th percentile means. So what does 80th percentile mean? So that means that the score was better than 80% and worse than 20%. Sometimes it's confusing. You might think 80th percentile is like the opposite. It's better than 20%, but no, it's better than 80% and worse than 20. So what about this score? What does this mean? If you've got 50th percentile, does that mean anything special to us? So what does it mean? It means that it's the score which was better than 50%. So it's better than 50%, and it's also worse than 50%. So we actually recognize that as what? We recognize that as the median. Right? That's exactly what we mean by the median. It's the score that has half of it below and half of it above. So the 50th percentile is also the median. Okay, let's take a look at this. A percentile provides information about how the data are spread over the interval from the smallest value to the largest value. For a data set containing n observations, the pth percentile, like the 95th percentile, divides the data into two parts. Approximately p% of the observations are less than the pth percentile, and approximately 100 minus p% of the observations are greater than the pth percentile. Okay, we don't have time to
Colleges
go through
and
the whole
universities
thing here,
frequently.
but I'd like you to go through this section in the book yourself, just this one section here. But anyway, the calculation works like this. Here we have 12 different numbers. And we want to know, for example, we want to find, in this case, they say find the 80th percentile. So we want to find the 80th percentile. We have the score of 5710. We have another score of 5755. We have another score of 5855, all the way up to 6325. And I want to find the 80th percentile. And the way they say to do that is, first of all, they denote that by L, the location, 80. So they call it L sub 80. L sub 80 is written here. And the way that you do this is you take 80 over 100, 80 over 100, 80 over 100. And then you take the total number of elements in the data set. So in this case, there are 12. You take 12 plus 1, n plus 1. So we get 80 over 100, 12 plus 1. That gives us 10.4. So we want to find the 80th percentile score. And this tells me that it's somewhere around here, somewhere around 6050 or 6130, somewhere in there is the 80th percentile score. And that came from this calculation that we just did. And so it's 10.4. So what you actually do, what they actually want us to do is go 40% between the 10th and the 11th. So the distance between the 10th and the 11th is, what is that? 80, because this is 6050 and this is 6130. So there's 80 points spread there. So we want to go 40% of that. And that turns out to be what? 40% turns out to be, anyway, somewhere between, as I said, 6050 and 6130, and 40% of that is 6082. So that would be called the 80th percentile score. Okay, so anyway, I'd like you to go through and read this section yourself, and then I'll be able to give you homework that includes this concept as well. Okay, that's all for today.
Can we leave now, Professor?